We're back with the notes for 6.2. Today we're going to be learning how to solve a system of equations when you have three variables, and we're going to be doing it by hand. Later in this unit, I'm going to teach you two other ways to solve the same kind of problem, but for today it is going to involve a lot of work. I'm not going to read you through the steps. We're going to jump straight into the problems, but here's my suggestion. This would be a good notes video for you to watch the whole problem, follow along with it, and then go back and copy it down. Number one, that makes sure that you know how much space is needed for each thing. Number two, that makes sure that you can focus on listening and you're not missing anything when you're writing it down, okay? All right, we're gonna go ahead and move straight down to the bottom. I have color-coded the problem, so hopefully you will be able to see using my colors. I'll change them to like purple or orange or green when two equations come together, but I'm gonna try and help you navigate where the equations are coming from, okay? All right, so here's our goal. First thing we're gonna try and do is treat it like you only have two equations. We're gonna put two equations together and try to eliminate one variable, okay? Let's start with that. If I look right down the line, I notice that pink and blue, both of them have a positive x and a negative x. So I'm gonna copy that down. We're going to try to eliminate that first two. All right, so I'm going to do x minus 2y plus z equals a negative 3. And my blue equation is a negative x plus 3y minus 4z equals a negative 6. When I solve these two problems and I put them together, that means my x is canceled. I'm going to change it to purple now because pink and blue are coming together. And I'm going to end up with just 1y minus 3z, and I'm going to start tagging my z's with that line through them so you know they're not twos, equals a negative 9, okay? All right, we have done our first step. The second step is to try and do two more equations, different equations, but eliminate the exact same variable, okay? So we're going to try to eliminate the x's somewhere else, okay? If I look at this problem, I notice that I could take the top equation, the yellow one, and the pink equation if I multiplied it by a negative 2. So here's what I'm going to show you. I'm taking the pink equation and I'm going to multiply it by a negative 2 so it cancels with that guy. Okay, I'm going to write those same two guys down here. So I'm starting with the orange equation. Orange is my yellow. So 2x plus y minus 3z equals negative 11. Again, that's a z. And my pink equation got multiplied by a negative 2. So we're looking at negative 2x plus 4y minus 2z equals 6. Okay? Now, when yellow and pink come together, they're going to make an orange. So I'm going to stay with an orange color. Okay? My x's, which are the same variable, are going to cancel. And we're going to add up what's left. So I have 5y's minus 5z's equals a negative 5. Okay, so we've eliminated all the x's out of our world. Right now, we're going to bring the two equations that we have made, the purple one and the orange one, we're going to bring them together to try to eliminate one more letter. Okay, so I'm going to switch and I'm going to show you where my pieces are coming from. So I'm going to start with the purple one. Now, purple and orange are not going to cancel the way that they are. So what I'm going to do is I'm going to take this equation, and when I rewrite him, I'm going to actually multiply him by a negative 5. And I'll tell you why. I want to change this y into something that will cancel with this y. I can't make a 3z go into a 5z. And without having to change both equations, it's easier to just multiply one of them. All right. So when I multiply it up here, now I have negative 5y plus 15z's, because I did negative 5 times negative 3, equals 45 because I did because I did a negative 9. That's my bad. That should be a negative 9. Because I did negative 9 times a negative 5. Okay? All right, moving back to the orange, we're going to bring this equation all the way up here, and we're going to copy him as is. Nothing changed on this one. Okay? All right. Since purple and orange don't really go together, we're just going to go to black at this point. All right, so my y's are going to cancel. If I bring my pieces of the equation together, we're going to end up with 10 z's equals 40. Divide by 10 gives me my first variable. My z is going to be a 4. Okay. Once you get your first variable, you are going to track backwards, okay? So we're going to track backwards. That black answer, the z equals 4, came from the purple and orange equations. I don't care which one you plug it into. For me, it's probably easier to do the y equals or the 1y minus 3z equation. So I'm going to go back to here and I'm going to plug that guy back in. Okay, so writing with purple, I'm going to start. I just had a y minus 3 equals a negative 9, and I'm going to put that 4 where the z was. Okay, solving that out using the purple equation, I have y minus 12 equals a negative 9. Add 12 to both sides, gives me 3. All right, so now I have my second variable. Now that I have my black variable and my purple variable, I can go back to the original 3 equations. It does not matter which one you use. For me, I would probably use the one with the least amount of negatives. It's looking like that would probably be the pink equation, the original pink equation. Okay, so if I go back to pink, I don't know what x is, so I'm going to write him out. I'm saying x minus 2 times the y, and my y is that purple letter 3, plus z, and the z was the black letter 4, equals a negative 3. All right, so we have x minus 6 plus 4 equals a negative 3. Negative 6 and 4 come together to make a negative 2. And if I add 2 to both sides, I get a negative 1. Okay, right now we have 3 different letters. We are going to put them all together to make our final answer. Remember, when you write a point, it's x comma y comma z. So my x is a negative 1, my y is a 3, and my z is a 4. Okay, I know that is a lot of work. It's basically 5 different sections. 2 sections to get rid of one letter, put those 2 sections together to get rid of a second letter, and then as you get your final variable, you plug it back in to get the other 2. Okay? Again, that's a lot of work. I would pause it for just a second, copy it down, and then let's go to the next problem. I think we have 5 to get through. Okay? All right, if you'll flip the page over, we're going to go to the back. And you have this whole sheet to solve just 2 problems. So if it was me, I would kind of divide my paper like this to give yourself plenty of room to solve this out, okay? All right, we're looking at the top equation. Again, I've colored it to try to make it a little bit easier for you. All right, I look at these right away and I'm noticing that the yellow and the pink can eliminate the y variable. So that's what I'm going to start with. My yellow equation, so x plus y plus z equals 3. And my pink equation, so 2x minus y plus 2z equals 6. When those 2 colors come together, they're going to make orange. So I'm going to eliminate the y's. I end up with 3x plus 3z equals a 9. Okay? All right, we need to eliminate the y's from another pair. So if I'm looking through this, it looks to me like I could do the same thing we did before. I could multiply the pink equation by a 2, because if he was a negative 2, he would cancel with this guy. Okay, so I'm going to multiply by a regular 2 this time, and we're going to do 4x minus 2y plus 4z equals 12. The blue equation is going to stay exactly the same. So 3x plus 2y minus just 1z equals 13. And I'm going to change to purple because if I put those together and the y's cancel, pink and blue makes purple. So 4x and 3x makes 7x's. 4z minus a z makes 3z's. And 12 and 13 is going to make 25. All right, now, my equations do not automatically cancel each other out, right? My purple and my orange don't eliminate each other, so we're going to have to multiply by something. If I look at it, it looks like I could change the equation. If I change my orange one, let me get orange real quick. If I change the orange one, and when I wrote him, all I did was multiply by a -1, I could make the z's cancel because I would have a -3 and a +3. So let's do it that way. Let's do -3x minus 3z equals a -9. Purple equation I'm going to keep exactly the same. So bring him up here. We're going to have 7x plus 3z equals 25. Now, I could have just as easily multiplied the bottom by a negative. I just would have ended up with a -7 and a -25. For me, it makes more sense to make the smaller numbers negative so that I'm not really dealing with negatives in general. I'm just subtracting. Okay? All right. Orange and purple don't have anything in common, so I'm going to eliminate my z's. -3 plus 7 gives me 4x. -9 plus 25 gives me 16. And when I divide by 4, I get my first variable. X is 4. Okay? Now remember, once you get your first variable, you are going backwards. So you have to go back to the purple or to the orange equation. I'm going to take that 4 and I'm going to plug it back into the one with the lower numbers, so my orange. So if I go back to the orange equation, we are going to do 3 times 4 plus 3z equals 9. I'm going to plug that 4 back in where the x was. So we're going to go 12 plus 3z, again that's a z, equals 9. If I subtract 12 from both sides, I get a -3. And if I divide by 3, I get my z value, which is a -1. Okay? All right, now I have my x is 4, and I also have my -1 for the z. I think the definitely easiest equation is that yellow one up at the top. So I'm going to put in my z, and I'm going to put in my x so that we can solve that out. Okay? All right, so writing out with my first equation, my x was a 4. Let me write that in there. 4 plus y plus my z is a -1. Equals 3. All right, so I don't really have any distributing or anything to do, so I'm just going to put those together. 4 and a -1 is going to make it 3, so y plus 3 equals 3, which should just give me y is 0. All right, putting everything together, remember my answer goes x, y, z. So x is 4, y is 0, z is a -1. What I would do is pause your screen for just a second, copy everything you need, and then we'll move on to the bottom. Perfect. Okay, moving on to this bottom question. I know you can still kind of see some of it, and that's okay. But I want to give you plenty of space to work this question out. All right, so if I'm looking through this, I notice from the start that the pink and the yellow equations, they can eliminate the y. So let's go ahead and start with those ones. So I'm going to go x plus y plus z equals a -1. Going pink equation, 2x minus y plus 2z equals a -5. Getting back to my orange, y's are going to cancel, and I add up what's left. 3x plus 3z equals a -6. Okay? Looking, I have to cancel the exact same letter, so I'm going to have to cancel the same y's. It looks like it's always kind of easier to multiply the pink one. Okay, so on this problem, the pink one, if I multiply it by a 2, he would turn into a -2y, which would cancel with this guy. It's not always going to be a 2. It just kind of is working that way in the notes. Okay? All right, so if I start with him, we're going to have 4x minus 2y plus 4z equals a -10. And the blue equation is staying the same. So -x plus 2y minus 1z equals a 4. Change into purple, because if I put them together, I get purple. Remember, the same variables have to cancel, so we end up with 3x plus 3z equals a -6. All right, now remember to eliminate. And to get rid of the next variables, I need them to be the opposite. Right now I get lucky. I got 3x and 3x. I have 3z and 3z, but I have to change the sign on one of them. It doesn't really matter which one. I'm going to change the top one. So if I multiply this guy by a -1, I get -3x minus 3z equals a positive 6. Bring my purple equation up. Positive 3x plus 3z equals a -6. Now, look what happens when I add these together. I cancel out the x's, but I also cancel out the y's. I don't have anything left, so I'm going to put a 0. I have no x's, no y's. Positive 6 minus 6 also gives me a 0. So in this case, I have no x, no z, and I can't make a y out of that. So when I look at this problem, I don't have any point. What I end up with is infinite solutions. I want to make a quick reminder. If you had, this is kind of just a note to self, if you had gotten like 0 equals 5, that's when we say no solutions. But if you get 0 equals 0 and those are true statements, then we do want to say we have infinite possible solutions. Okay? True statements give us infinite solutions. All right, if you would pause the screen for just a second, go ahead and copy what you need from that problem, and we are moving on to the word problems on the next page. Perfect. I know that there's 2 page 18s. When this was typed up originally, there was not a lot of space to work, and I wanted to make sure that you have that. So if you go to the next page, you'll notice both of the word problems are down at the bottom. You have the whole top to work this problem. Okay, so you don't need a lot of space for the bottom one. I'm going to have us work the top equation on top of the line, and we'll use below the line for the bottom equation. Okay. All right. In this first problem, we're going to have to not only solve it, but we're going to have to write our own equations for that. So let's go ahead and look at the first equation. It says you have $33 to spend on 24 balloons. So we're looking at 2 things right now. We're looking at money and we're looking at balloons. If I go through this problem, I'm going to read it first so I know how many variables I have. It says birthday balloons. Change this real quick. Birthday balloons cost $1.50 each. Congratulations balloons cost $1 each. And get well soon balloons cost $2 each. Okay? So we know the total is 24 balloons, and we know the total we spent on all of them. That right there gives us our first 2 equations. I'm not going to color code it all this time. I'm going to use black as we write the equations, and then I'll use colors as we start showing the work. Okay? All right, so as I write out my first one, I know that all my birthday balloons plus congratulations plus get well soon, and I'm just using the letters they gave me, are going to make a total of 24 balloons. I know that if I put their prices in there, that the total is $33. So let's do that. $1.50 for all the birthday, $1 for all the congrats, and $2 for all the get well soons, make $33. Okay, now in order to solve with 3 variables, I have to have 3 equations, right? So I need one more equation. That's where that last sentence comes from. You want twice as many birthday balloons as the other 2 combined. Don't write this yet, just listen. That means that my birthday needs to be twice as much as the other 2 combined. So the other ones would be my congrats and my get well soon. Now, you could write it that way, but that doesn't make it very easy for substitution. So I'm going to think about it like distributing this out, and then I'm going to write this differently. I'm going to write it as B equals 2C plus 2G. Okay? All right, those are my 3 equations. If you wanted to write them down from the start, that is fine. Otherwise, you can listen till the end and then copy everything at once. Okay? I'm going to do 2 things to make my life easier in this problem. First of all, I'm going to remind you that we can use substitution. We don't have to use elimination all the time. So from the start, I'm going to substitute this part in for everywhere that I have a B. Okay? Second thing is I'm going to remind you that you do not have to write 1.00. That is the same as just saying 1C. Also, you don't have to say 1.00G. You can just say 2G. Okay, so as I write these out, I'm going to simplify them just a little bit. All right, writing out the first one, I'm going to have 2C plus 2G, that's my plug-in, And then I'm going to bring over the rest of my equation. Plus, oops, let me put them in black so you can see it. Plus C plus G equals 24. Okay? Nothing to multiply, but I am going to combine my like terms. I'm going to end up with 3 C's and 3 G's to make that 24 balloons. Okay? All right, let's look at the next equation. If I start with that 150, but I'm going to plug in for the B. So now I plug in my 2C plus 2G and bring out the rest. I'm not going to say 1.00. I'm just going to say C. And I'm not going to say 2.00. I'm just going to say 2G. That gives me my 33. This one I do have to multiply. So I'm going to distribute the 1.5. We get 3C plus 3G. Bring down the rest. And then I can combine. So I'm going to have 4C plus 5G equals 33. All right. Now, looking at these two equations, I'm going to change colors to pink and to blue so that you can see what I'm talking about. These two equations are going to have to come together so that I can cancel out either C or G. 3 can't go into 4, 3 can't go into 5, so it does not really matter which one I cancel. For me, the numbers are smaller if we go with the C's. Okay? I need the numbers to match. So the least common number, least common multiple that 3 and 4 can go up to is a 12. So here's what we're going to do. We're going to multiply this whole row by a 12. By a 4 to get to a 12. Okay? And I'm actually going to make him the negative. I'm going to multiply this whole blue row by a 3 to make him a positive 12. So let's write out what we're going to get now. I'm going to end up with a negative 12C, negative 12G, and a negative 96. For my blue equation, I'm going to end up with positive 12C, positive 15G equals 99. Okay, so all I did was distribute those. I am bringing this blue equation over here, and I'm bringing the pink equation down from here. Okay, pink and blue together make purple, so I'm going to use purple to eliminate. Eliminate the C's. Negative 12 and 15 gives us 3G. Negative 96 and 99 gives us a positive 3. So right now, we have our first variable. That tells me that I have one get well balloon. Now, we still have 2 other variables to solve for. So remember that you are going backwards. If I just got my G and I got it from the pink or the blue, I have to go back to pink or blue to get my answer. So I'm going to go back to the pink because the numbers are smaller. I'm going to plug that in. 3C plus 3 times my G number equals 24. Plugging in that 1 where the G was, let's solve it out. So 3C plus 3 equals 24. Subtract off a 3 from both sides, gives me 21. Divide by 3 gives me 7. So I have 7, and those are the congrats balloons. I can't spell congratulations, so we're just going with congrats. Okay. All right, now that we have purple and pink, we can go back to one of the original equations. My suggestion would go back to the yellow one where we started with. Okay, I think that one's probably the easiest to get from. Okay, so we're trying to solve for B. I know that my B is 2 times the C number plus 2 times the G number. So in this case, my C number was 7. My G number was 1. So 2 times 7 is 14. 2 times 1 is 2. So that means that my B is 16. I have 16 birthday balloons. Now, since this is a real world problem, I do not need to write it out like 16, 7, 1. It is a real world problem, so you are fine as long as you have your units. If you want to pause for just a second, go ahead and copy that down. We're going to do one more problem, but the next problem doesn't ask us to solve, so no worries. Perfect. Going down to the very last question, here's what our objective is. Objective is, if I look down at this final question here, it says write the system of linear inequality, so make sure you know that's a less than greater than, that shows the various number of boxes of raisins that you could use or that you could buy, and then sketch the graph. Okay, so we're going to need two things here. We're going to need two equations. We're also going to need a graph. Okay? All right, it says you are a counselor at a summer day camp and you've been sent to buy drink boxes and boxes of raisins for the campers' morning snack. Each box of raisins costs 10 cents and each juice box costs 40 cents. You have $26 and you want to buy enough so that each camper will have at least one box of raisins and one juice box. There are at most 40 campers. Okay, so let's start with that part. All right, hopefully you're okay with using R and J for our raisins and juice. Let's start with the money. So the first thing I know is that my raisins are 10 cents each and my juice is 40 cents each. And I know that if I go and I spend all my money on all the raisins and all the juice boxes, that I only have $26. Now, this is an inequality. So if I can only have $26, I cannot spend more than that. I could spend equal to it, but I would have to stay less than or equal to it. Okay, I can't spend $26.50. Okay, all right, there's my first inequality. Second inequality, you have two kind of ways to look at this. You could say, all right, well, if each of my campers is going to need one juice and one raisin box, maybe you're thinking, okay, I need more than 80. But you have to think about it for each one. We actually are going to have two more inequalities for this one because I need to know that everybody gets a box of raisins and I need to know that everybody gets a juice box. So that means that I need more than or equal to 40 of these, and I need more than or equal to 40 of these. Not just 80 total. I don't want everybody to have two juice boxes and no raisins. Okay, we want at least one of each. Okay, all right, I'm going to show you this visually on a graph from Desmos so it makes a little more sense. But all I did was graph each of those three. One's going to be a horizontal line, one's going to be a vertical line. And I'm trying to isolate the triangle in the middle. So we're going to sketch this out once you see the graph. Okay, all right. If I sketch that graph out, I have a horizontal line. I called this one my juice. Higher than 40, one vertical line saying that my raisins are more than 40. And then this diagonal, this is showing my price. Okay, so I have to stay under that $26. We're going to sketch this triangle on our paper. Okay, so let me move him out of the way. All right, so here's what that's going to look like. Only focus on the first quadrant. We're going to draw plus signs that look like this. And then we're going to draw a diagonal that looks like this. We're going to label a couple of points on there. Okay? So if I can remind you, let me scoot this out of the way. There we go. All right, so this point up here is going to be 40, 55. This point is going to be 100, 40. And this point is going to be 40, 40. Okay, so when you write out your answers, your raisins are going to have to be between 40 and 100. So this is my R, this is my J. Raisins are going to need to be between 40 and 100. But my juice boxes are very limited. My juice boxes are going to have to be between 40 and 55. Okay? All right, we do not have to solve this problem, so if you will just make sure you have everything copied down. I know this was a long video. Thank you for sticking with it. You are not expected to start the homework until we get into class.